Okay, so in the last video, what we were able to do was upload an image of Kirby and just display him to the screen. Okay, so what we're going to do in this program is, or at least in this video, is we're going to move that image. Okay, so we're going to come down here to the player class and we're going to set a new attribute here. So we're going to say self dot, let's say speed underscore x equals to 5. All right, and then I'm going to come down again and say define update, and inside the update itself, and what we're going to do is we're going to try to move this Kirby or this image, or I should really say is that we're moving the rectangle around the image by 5 pixels every single time that it iterates. So the way that we do that is we take this speed and what are we adding this 5 to? Okay, so above this we had a center, okay, and that center was comprised of an x and a y. Right, so once you create a rectangle, you're actually open up to all of these options. So in the last one we had all of these options here. The moment that you create a rectangle around an image, you can use all of these options and more. There's actually a lot more than this, but these are the ones that we'll be using. So we can say self.rect.x, and currently wherever the x is positioned, in this case right now it's positioned at width divided by 2, which is 300. Okay, whatever that is now, we're going to add, so plus equals the speed. So if it's at 300, 305, 310, 315, so self.speed underscore x. Okay, and now if we were to go ahead and just run this, you'll see that it should just be moving a little bit, right? And it goes off the screen, and then that's pretty much it. So you can like imagine now if you're playing one of those shooting games and you have like a ship and you're using the left and the right arrow key. Well, if you go all the way to the right, right, in our current program, you just go off the screen and you'll never come back unless you press the left arrow, and then you have to wait for the same amount of time that it took for you to go off the screen. So what we're going to do now is we're going to have it so that when the Kirby goes off the screen, it'll actually come back around. So let me explain how that's going to work. Okay, in this we have a regular Kirby, and what's going to happen here is essentially if the Kirby's here, okay, it's going to come all the way, okay, it's going to go off the screen, and when it gets to this piece right here at the end, okay, then we're going to basically start a new image that's going to come around like this. Okay, so now how is that going to work? Let me just see if I have my pencil here. I do. All right, so we have this guy here. Okay, now if I were to wait until Kirby gets to the end, all right, and then I start a new image, it's gonna look like it gets to the end, and then it's gonna cut out and paste. But we want it to be flowing. So the way we're gonna do that is we're gonna look at this as when this gets to the end, what part of the rectangle is this? Okay, this should be self dot rect dot left. So this is actually the left portion of that Kirby, right? If we go here and we just go back really quickly, you'll see that this is actually like the left portion of whatever the image is. Then immediately after that, so if self.rect.left is greater than, okay, now remember if our x and our y starts here, that means the distance from here to here is actually going to be the width, which is going to be at this end. So if it's greater than the width, all right, then we'll take self.rect.right, okay, and then we'll add 5 to that. Right, so the way we're going to do that is we're going to say now if self.rect.left, that's the edge of the Kirby on the left hand side, if it's greater than the width, right, we're going to set now self.rect, oh I should say left, I don't know where I put blanks, okay, rect.right equal to 0. And again, because I think that was still like a little bit fuzzy there. All right, now when we move the left portion, as soon as this gets off the screen, we're going to set the right part of the rectangle equal to 0, right? So it's going to just start from here, and then it'll add 5 every single time, or rather this way it'll add 5 every single time. Okay, so let me just show you what that's going to look like. If we go ahead and rerun this, all right, see how it looks like it's smooth and perfect? It looks like it's literally just looping back around. What's actually happening is that once it gets to the edge, okay, we're literally jumping it and replacing it back at the beginning, but for the user, this is going to look like a nice smooth image. Okay, if, however, we were to do it the initial way that we might have thought, whereas if this got to the edge, okay, so this is the right, let me just show you what would have happened if you would have done that. Okay, if you would have set it to there, this is what it would look like. See how it looks like it literally, it's not smooth. It looks like it was taken and put somewhere else. And so that's why we wait until the end gets off the screen. And once the left side has left the screen, then we can go ahead and have a nice smooth image. Right. Now the other thing that we're going to do now is we're going to make this image kind of like bounce. Okay, so we're going to make it look like it's bouncing up and down. So the way that we're going to do that is, let me see if I actually didn't plan on doing this, so I don't really have anything prepared for that. So let me just see, clear annotations, and we're going to try to figure this out. Okay, so right now the Kirby's here. The way that I want to have this is that the height right now, I'm writing in white, the height right now is, what was it, 800? So the way we're going to think about this is, let's say that the Kirby gets here, and let's say that this line is 200, and let's say that we'll have him bounce between this 200 and the 600. Okay, so we want it to look like this. Okay, it's starting here, it goes up and down and up, and then it goes loops back around and stuff. Okay, so if we start in here, that means that we need now a vertical ascent and descent. So we're going to have a vertical speed, which tells us that we're going to need a self dot speed underscore y, and we can set that equal to 5, we can set that equal to 0, whatever it is you want to set that equal to right now, it doesn't matter. And what we'll do now is down here we'll say self.rect.y plus equals self.speedY. So as soon as this starts, okay, it's just gonna go straight up. And let me just show you what that would look like, because I like to show the errors as well. Okay, so as soon as this one's just, oh, I'm sorry, it's going straight down. And the reason why, and I totally forgot about that for a second, is because you remember that on the screen, the height increases as you go down. Okay, just finishing up making math videos, and so of course I'm thinking a regular coordinate plane, it goes up, but in Pygame, the image will actually go down and your height increases. Okay, so this is going all the way straight down. What we're going to do is we're going to have boundaries. So we're going to say now, if self.rect.top, okay, again going back to the image here, and we're saying if the top of this image, okay, so if this top right here is going to be greater than, or I should say, I'm sorry, less than 200. So if this gets here, okay, this might maybe be like 199 or something like that, right? If it gets there, then we're going to then put the speed to be negative, positive, and come back down. All right, so we're going to check it as it gets less than 200. Once it identifies that, we'll change the speed and start adding and go back down. Once it gets down here now, okay, once it gets greater than 600, we'll put the speed as negative and let it go back up. So let's say if self.rect.top is less than 200, then self.speed underscore y. All right, now remember, if it goes to the top, we want it to go down, so we're going to be plus equals to 5, or so I should say equals 5. And then if self.rect.bottom, so if the bottom of the image is greater than 600, then self.speed underscore y is equal to -5. Okay, the reason why we're not we don't have to put like any of these things is because if we were to go through the program, Okay, it's going to check to see, all right, are you below 200 pixels vertically? If so, it's going to set the speed to 5, so when it loops back around, it knows, okay, I need to take the y coordinate and add 5, because right before that, I determined that I was less than 200, I can add 5. If it goes way too low, if it goes past 600 pixels on the bottom of the screen, then we're going to set the speed to -5, which means that when it loops back around, it's going to go to the y coordinate, and instead it'll be adding a negative, which really just means that I'll just be subtracting and going back up. Okay, so this is what it will look like at the end of that. So it looks like it's bouncing up and down. Okay, and you can play around with them and you can change the numbers, but this is essentially an idea of how the sprites work and how to make it look fluid, because making something look fluid is really what makes it nice and smooth and makes it a fun game to play. So in the next video, what we'll do is that we will eliminate the Kirby image, and we will create a pygame.surface, and we're going to start to build the game from scratch, and then at the end, or maybe like towards the middle, we'll start importing the correct images for them.